then what this means is you can at any point of a time discharge 700 milliamps of current, right? If you discharge 700 milliamps of current, then this battery will last for 1 hour. So what we usually do is, if the rating says 700 mAh, we discharge only 700. So rating versus actual discharge, if these are basically the same, then we call it as 1C rating, which basically says what is the rate at which actual discharge is. Suppose if I say I'm discharging at 2C rate, it means that I'm discharging at 2 times the rated, which means 700 into 2, I'm discharging 1400 milliamperes of current. If I discharge 1000 milliampere hours of current, then this 1 hour, this will fall down to 30 minutes, right? So it's basically related. The takeaway is don't discharge at much higher rates. Discharge what holds true, same holds true for charging also. So when current goes out, you have heating losses. When current comes in also, you have heating losses, which is why the biggest problem we have with electric vehicles these days is they take 8.5 hours to fully charge. How long does it take for your mobile phone to charge? I don't know, maybe like about until about 4 years back, I would say like about 6 to 7 hours it would take for a phone to charge. Now you have OnePlus phones with 45 minutes dash charge. So in 45 minutes, it charges your battery to about 80%, 90%, right? I don't remember, maybe sometime in the recent past, I don't remember a point where I had to charge a phone for more than 3 or 4 hours. So I come to my office, I put it on charge. By the time I get up for lunch, it's fully charged. I no longer charge it overnight, right? So that is possible only because of improvements in battery, manufacturing techniques. So if you are able to manufacture a battery with very low internal resistance, then you can basically charge and discharge at much higher capacities, right? So this is something which we have. So 8.5 hours is the normal charging rates, whereas you do have something called as supercharging or DC charging. We look at all of those things where they have taken this 8.5 hours and they have been able to reduce it to about 4 hours or something thereof, right? Teslas have got something called as supercharger networks. So all of these things basically to do with your battery technology, fundamentals of your batteries, right? So what does it leave us with? Let's just like quickly jump ship here and let's go and let's see what does it leave us with, right? This is battery. Yes, let's quickly go here. Okay, so this is basically me talking about batteries with different charging limits. So you cannot properly charge it and discharge it. So you have something called as a battery management system, a BMS, to take care of this. So this is basically like something which we need to take care when we are charging it. We did talk about it, right? So I said different cells have different capacities, and because they have different capacities, you need to have a controller which will basically balance out how these things charge it. Now comes the most critical thing, which is the charging systems. So you do understand by now, probably you do understand that you cannot take any charger and charge any battery, because for you to charge a battery, you have to understand what is the different type of cells which is present there, what is the individual capacity of the cells, and only if you understand all of these things, you can actually go and you can connect a charger and you can start charging it, right? You do understand this, right? That is why it becomes really complex. So most of us really think that electrical vehicle charging is a straightforward thing. Take any charger, plug it in, it charges. No, it doesn't happen like that, right? So you need to really think of a lot of things. So the first thing is you need to know at what rate you can charge it. Maybe I've gone and I've purchased a vehicle. I mean, sorry to stereotype, don't take me in the wrong sense, but maybe I have a China-made electric vehicle, right? Usually we tend to assume that China-made stuff are low quality. I'm not generalizing, but just say, for example, I've have an electric vehicle which has got a poor quality batteries in it. I have a German-made car which has got really high quality batteries in it, which means I can charge them at different rates, right? How does one single charger address these two issues? How does a charger know if this is a if this is a lower quality battery or if this is a higher quality battery? How does it know, right? That is the first problem that we have. Now, second problem is How do you know that the batteries are full or batteries are not full? How do we know that this battery pack can take much higher charging rates? This battery pack cannot take much higher charging rates. How do we know that Tata recommends you charge at a rate of 1 kilowatt, whereas Hyundai recommends you charge at a rate of 2 kilowatts? Because we cannot make separate charging infrastructures for each vehicle type separately. We should kind of have a uniform way for them to start, charging everything interchangeably, right? So these questions, when you ask yourself, you basically come to the understanding that the reason why electric vehicles have not gone mainstream is because we have not been able to fully answer these questions, right? And of course, the second thing being, if you are charging at 1C rate, so I said 1C rate is you don't overcharge it, you charge it at a very conservative rates. Now, suppose you have a battery pack which has got a 10 kilowatt hour capacity and 60 volts battery pack, right? So you would be able to basically divide 10 kilowatt by 60 volt. You would get a capacity, a colorimetric capacity or a current capacity of somewhere about 160 ampere hour for this battery, right? So 160 Ah is basically the colorimetric capacity, which means you can charge or you can put in 160 amps of current at any point of a time. This is basically how it basically works, right? So now if you try charging it with a domestic supply, which has got a 15 amps current, right? 15 amps is what a domestic supply can give you. Now, if you do that, then basically what you can achieve, right, is going to be like the charging time which you can achieve with a 15 amp supply is going to be 11 hours. If you want to charge it at a much higher rate, then you will have to go for a public infrastructure. So public infrastructure is where all the whatever questions I asked you. So that is where all of those things start coming into place, which basically got the manufacturers to start thinking. And they said, you know what, we cannot just have a charging socket, right? So how does your mobile phone charging socket look like these days? Or take the charging pin for a let's say something like your I don't know, laptop. How does your laptop charging pin look like? So maybe you have a barrel socket like this. You have maybe a hole in the center. So here you have positive, in the center you have negative, something like this. So basically, forgive my drawing skills, but basically what I'm trying to tell you here is that current charging systems, like how we have seen it, they only carry voltage or they only carry current, right? So they don't do anything else. They basically conduct current and your battery gets charged up. That is what they do. But as far as automobile goes, this is not sufficient. We also have to transfer some data. What kind of a data we have to say? So this guy has to say, I need 50 kilowatt hours of, this is my capacity. My capacity is 50 kilowatt hours. And currently I'm at 85% SOC, which means this is now understanding, okay, I only have to put in 15% SOC. And this is saying, hey, I'm a German make, so I can take up to 100 amps. Okay, this is basically like this onboard ECU has this information. So through the charging cable, it's giving information to the charging station. So charging station is like, okay, fine, take it. You want 100 amps, I'll give you 100 amps. It just puts that in. And once it's completely put in, this says, hey, I've reached 98%, slow down, this slows down. It says 100% stop, this stops. And finally, it gives a bill which says, you owe me 200 rupees for the charging. Now, this thing comes in here. Maybe this says I've got 100 kilowatt hour, but I've got only 5% SOC. So I can take up to 200 amps. So charge me at a much higher rate. So in order for all of these things to happen, these systems will have to start talking among themselves, which led the automotive manufacturers to start innovating with respect to what are the type of charging cables they can start using. So we started with mode one, which is basically a plug point, which you plug it into this charging socket, nothing else. But then we started improvising on it and we came with a mode two. So mode two is where you have some kind of communications also possible, but the communication is not between the charging system and the car. Basically, the communication module, what it does here is this basically cuts out charging whenever the battery is full. So this is again manufacturer specific. And then what happened is manufacturers started giving a wall mounted socket. So you'll have to understand with both of these things, it's going to take 11 hours. Not 11 hours, but with a 15 amp socket. Whereas with this, what happened is the manufacturers were able to take a direct connection, a dedicated charging connection, and maybe they give a 50 amp supply. So with a 50 amp supply, this charging is basically going to happen in 5 hours. This is also manufacturer specific, which means if you have a Tata Nexon, Tata has to give you this thing and it works only for Tata. But this is the public infrastructure that you have. So you see public infrastructure, what happens is it is compatible with a whole lot of things. And you see in both of these cables, the communication is inbuilt, which means you have pins here. Only the 3 center pins are used for power. The 2 pins at the bottom, they are used for communication. Similarly here, 2 pins are used for communication. So you have different standards for this. So we call it as mode 2, mode 3, mode 4. Mode 3 is again like something which we use for domestic applications, whereas mode 4 is direct DC charging. And direct DC charging is you don't kind of like convert your AC current into DC and then you put it in. What you basically do is you directly get DC current. The converter is basically sitting here, so you charge DC current inside to this directly. Whereas in all of these systems there is AC here, battery is DC, so here there is an AC to DC conversion happening. Whereas in this case, DC is being supplied, there is no AC-DC converter. There is, but it is being bypassed and it directly charges the battery. So if you don't have an intermediary in this case, then you can charge it at much higher rates. But sorry about it. But what is actually happening, where we are actually stuck is the manufacturers have not been able to agree upon certain charging standards. So right now, if you take charging standards, we basically have something which is predominant in China. We have Japan, which is basically promoting something. Then we have Tesla, which has got their own things, and you also have European standards. But European standards not much, because the predominant China electric vehicles, they are from the Japanese manufacturers, your Nissan, Honda, plug-in hybrids and all those things, Tesla, of course, and China has their own standards. So basically what we have seen right now is we've looked at batteries, we've looked at the problems with batteries, and we have reached a point where sorry, we could ideally discuss about chargers, but we see that even with those chargers, there is some kind of a internal struggles with the manufacturers, and unfortunately they have not decided what kind of a thing to go with. So in these cases, if suppose India is to roll out a standard, what will they roll out? Will they go with Japanese standards because Japanese cars are here, Japanese, Korean, or do they go with Chinese because China is what is going to supply the majority of the the electric 2-wheelers, 3-wheelers are going to come from China probably. So do we go with Chinese standards, or do we go with Tesla, which is basically the most advanced charging standards there is, and of course their technology is much superior as well. So do we go with the Tesla standards? Unfortunately, we don't have answers to these questions yet. So unless we have answers to this, there is not much we could probably go and do in terms of rollout of this infrastructure or even design something. So until that happens, we are basically stuck with it. And of course, India has its own standards, which they have started coming up with. But the bottom line, the bottom point is that we are not ready to roll out a single unified type of charging as of now. We are still waiting for things, and we would be able to start doing this once we have a little bit more clarity on how we need to take things forward. So I'm just going to end the session with this here. I think we have another 10 minutes more. So I'll stop the session with this, and let's probably take up the Q&As if there is anything.